We've been talking about investigating slopes of linear equations. Today we're going to talk about intercepts of linear equations. So let's start. We've already talked about a few things involving linear equations. We know that the slope-intercept form, write this with me. Slope-intercept form looks like this: y equals mx plus b. And we've been talking about slope. We know that m is slope. There's your slope. And you guys are writing this at the top, not over the writing. I just didn't have enough room. And the b, that's what we're going to be talking about today. That is the y-intercept. Okay, so number one says, can more than one line have the same slope? If more than one line has the same slope, what makes the lines different? So they're going to give us some examples here, and we're going to graph them. So if you look at these Roman numerals 1 through 5, you'll notice that they are all in slope-intercept form. So remember, y equals mx plus b. And I can tell from looking at these equations that all of these equations have the same slope. Remember, the number in front of x, or the coefficient, is your slope. That's your m. And they all have a 1. And the b is what's going to be different this time. Okay? So that means that whenever I graph it, we're going to look at the y-intercept. So y equals x goes through the origin. Think about it, you could put a plus 0 on the end, and that's how I know it goes through 0. And I want you guys to go ahead and do your change in y over your change in x, because we know our slope is 1. Sorry about my dog barking. He barks way too much. Okay, so you guys go ahead and graph that. I'm going to go deal with my dog. Okay. So if I start right here at the origin and I go up 1 over 1, so I go up 1 over 1, up 1 over 1, and you can make some points along there whenever you make your line. That helps. And then get a straight edge and go ahead and draw your line. Okay, now what I want you guys to do is I want you to go ahead and graph number 2, or Roman numeral number 2. We're not going to worry about Roman numeral number 3 and Roman numeral number 5, because that's going to be really hard to graph on this little graph. Go ahead and pause it. Graph you should have 3 lines drawn in your graph by the time you're done, and then we'll talk about it. Okay, whenever I drew my line y equals x minus 6, my y-intercept was at minus 6. So I started there, and then I did my slope up 1 over 1, and I just made a whole bunch of dots. Then I'm going to draw a line through it. And when I did y equals x plus 3, I started at plus 3 right here. And I did the same thing with the slope. I went up 1 over 1, and now I'm going to make my lines. Okay, so this is what your graph should look like. Make sure that your slopes are going in the positive direction. Remember your slope face. I kind of like to draw it just because it's fun. So we've got positive slopes. So we want to make sure they're going in the positive direction. Okay, now let's answer B, C, D, E, F, and G. What observations do you make? They are parallel. When they have the same slope, they're parallel. What is the slope of the lines? Well, we already talked about that. It is 1. Alright, D, how does addition or subtraction of a B value change the line? It changes, you guys probably know this, I would prefer you to put it in your own words. It changes where it crosses the X and Y axis. That's an and y axis. What is the name of B? That is the y-intercept. Predict the graph of y equals x plus 7. Sketch it above. And go ahead and pause it, use your calculator, and see if you were right. Complete the sentence. Lines with the same slope are parallel. Alright, let's look at the other page. I'm going to fill in the beginning blanks for you, and then I'm going to let you guys finish this activity. In a function, an intercept is the point at which the line crosses an axis. If it crosses the y-axis, it is called the y-intercept. And if it crosses, and the point is 0y. If it crosses the x-axis, it is called the x-intercept. And the point is x0. The x-intercepts are also known as the zeros of a function. Because the x-intercepts are where the value of the function is 0. In other words, write this in there with me too. A function, remember we've talked about, is f of x. That's the name of a function. And it would be where the function is 0. Alright, what I want you guys to do is I want you to go ahead and find the x-intercepts and the y-intercepts from the graph. So here's your lines. Look at where it's crossing the x-axis and look at where it's crossing the y-axis. I'll give you a hint. If you're looking for the x-intercept, the number is going to go where the x goes. Remember, in an ordered pair we have x comma y. So put the x where the x goes, and then the other number, or the y, is always 0. Same thing for the y. This time we're putting the number where the y goes. X is always 0. Okay, there's your hint. You guys go ahead and finish this. Check with your teacher on your answers.